Life be like, yeah, my life be like, yeah, yeah, my life be like, yeah, my life be like. Times like these that make me say, yeah, Lord, if you see the please come my way. Like, living right down to all when I stray. Yeah, long sacrifice in the price my life be like, living like a fingertip. Sometimes I fall, I slip. Yeah, I walk feelings I be more like you. Yeah, not to put your fire with me.
Hello, everyone, and welcome back to our second session in the Modern DevOps, the toolkit to empower your development team. I'm Batel Zor, and nice to meet you all. I'm a developer advocate at JFrog. I really love Marvel's movies and sometimes DC too, it's also okay. But we can talk about that later on. Feel free to reach out to me later. Today, our goal with this three-part webinar series is to provide you some practical tools and strategies to help you to deliver high-quality software to the market quickly. This series is designed to give you, as a developer's perspective on the software development process. We would like to uncover the hidden challenges and provide actionable solutions to streamline your software development lifecycle. So today in our second session on this series, we're going to focus on optimizing the build process for maximum velocity. We will talk about the build process where we will dive into the coding and code review process and identify the ways to eliminate bottlenecks so the developers can focus on writing the best code they can. In our next session, ready to ship, distributing and running software efficiently, we'll show you how to ensure your engineers have the visibility to address issues quickly with some best practices and tips to maintain software in production. Now, thank you again for joining us today. Thank you so much. And let's get started with today's session, Need for Speed, Optimize Build Processes for Maximum Velocity. Now, maybe some of you remember those engineers from the first session with Melissa. So as she mentioned, today it could be a little bit confusing, right? Your goal may be mix up, like we have a DevSecOps engineer. Is it a developer or a security engineer? We have DevOps engineer. What is his specific goals on the day to day? He should be part of the development team or operation or what's going on. And today we're trying to show you what will be the best way to show the engineers and let them think about security issues and how they can make it better for the development from the beginning. So let's get started. In our previous session, we talked about the code that's gonna build then to the deployment and the code review and everything we need somewhere here in the beginning. Like we had the code review, and we explained why it's important and critical to secure it too. Now, I want to focus on the build part and the build promotion, this part, all right? When we have the build and release candidate, and actually, I have a lot to share with you, all right? I have some experience with that. I saw many customers' environment, maybe friends' environment and development environment when I was during my career, and it sometimes sounds a little bit scary, a little bit funny, but think about this Friday. Maybe some of you remember the Friday of Log4j, right? I probably won't forget it in the next 10, 20 years. Like how you can find this dependency in all of this craziness, right? How we can make sure that I found everything that's using Log4j so I can easily eliminate it and change it to another package and so on. And today we're going to show you why it's important to secure every part of your deployment stage and why it's so important and how we can make it easily without doing too much stuff. So let's start from the beginning. Let's start from the build itself. So what is a build and what is part of the build? So we have CI/CD, right? Continuous integration, and we have also continuous deployment and continuous delivery or continuous distribution, whatever you're gonna want to call it. It's probably part of the CI/CD. And what does it mean at all, right? Why do we need a CI/CD? Let's imagine that our super talented developer wrote the code, right? Everything is perfect. Immerse it. Everybody are ready. And now we want to share it with the latest and greatest version, right? We just want to release it to the world because we make the best fix in the world or just created the best feature in the world, right? But before that, we need to make sure that it's good enough and test all the tests, right? Everything is fixed. We check that it's ready. We don't have any security issues, for example. And we would like to create a series of automated build and unit tests to ensure none of the proposed changes in this version cause any problem. Because maybe we just change something that harms something else and so on. And we want to make sure that it's ready, right, and fixed. But from my experience, I believe that we will find some bugs and integrations issues. So it won't be so easy to distribute it in one click to production, right? So in order to discover it much earlier in this process, ideally, a build will be triggered for every single commit. So that failure are catching the developer immediately and corrected it, right? We want to catch it in the beginning, so it's easier than we're getting something that it's already released and ready. So we want to make sure that we found it in the beginning, whenever we're just starting the first build. And continuous integration means you should have the ability to deploy a new build very rapidly because you have automated so many quality gates that would be otherwise need to be performed manually, like building, testing. That reduction in manual labor means you get a release, a bunch of small changes, right? It's probably better than one huge update. Probably some of you remember that before, like, I guess 10, 12 years we had a huge batch for every version, right? Whenever we're trying to when we tried to update our software, it took a long time. And today, sometimes we don't even know that it's updated already behind the scenes. And today, the idea is to make it more smaller changes so we also can get back very easily and we don't need to wrap it again with all the changes that we had. Now we have small changes, right? And you can also probably be more confident that your release isn't going to break anything because we just make small changes and we didn't change something so big. And whenever we're talking about continuous deployment, it's similar, but it goes kind of one step further, right? The deployment will be automated too. And in continuous delivery, there is still a manual quality gates involved before the update is up to the wild. But I think that continuous deployment it's kind of a great idea that's hard actually to make because you really need to trust your software, right? You trust your system. Everything is automated, even the distribution itself. Now, probably some of you remember this slide again from the previous session. I tried to make something similar, for my opinion, even cooler. I like it, Melissa, really, but I think this is better. So, because we're talking about Fast and Furious, let's talk about the potential bottleneck, all right? So, first, our developers found that the dependency that they need, they pull it from the internet, but they don't believe in caching, right? Who needs caching at all? We'll just download it again from the internet if we need it, right? It probably will be fine. So maybe not. Maybe it's not the right way to do that. So sometimes we need to make sure that we are caching the dependencies that in case we need it as part of our build, we won't get for example, and we can't reach out to our repository management. Now we convinced them to use caching mechanism, which is cool, but now they are caching a lot of things, right? They caching everything. They caching every dependencies that they are using. So they probably spending a lot of storage in that case, right? What will be the best way to solve it? Maybe a smart mechanism in that case. All right, so think about a server that you can store just the artifact that they are using by checksum-based storage, right? So let's say that Sharon and Sean using the same artifact in different places, just different project and so on. So each and every one of them need log4j, for example, both of them using log4j. So in case that I'm saving it in the file store only once, as you can see here, we can easily create kind of a pointer in the database, right, for different location. So I'll keep it only once, but create it for Sean and Sharon. They can both just pull it, but we save it on the storage only once, all right? And of course, it's configurability, and according to our needs, we can also clean up the unused artifact and so on, and clean whatever we don't need. But think about the idea, how much storage we can just save by using the same artifact in different places and saving it in the file store only once, right? And of course, we save time and cost because it's local cached in our mechanism, in our server in that case, and we can create our caching configuration. Like as you can see here, we can have the unused artifact cleanup, we can change the metadata retrieval cache and so on. We can just change it according to our prioritization and our needs in the organization, of course. And here's just a simple small example for the optimization. So we have the binary size, the actual artifact size, and as you can see in my case, I use it in different location, different project and so on, and I optimize it, not that much, but still it's better than nothing, and probably in a large organization, it will be much, much more than that. So we had the first one, dependencies from the internet, right? Probably we can do that better. Now let's talk about running and securing the build. So you can understand already the first reason why attacker would go to a software supply chain approach, right? Think about the idea that the distribution of the attack would be probably pretty big. Whenever we're going to the build, we can harm the whole organization. And now let's talk about the effort that an attacker need to invest in a supply chain attack, right? Compared to the classic targeted attack that we have seen a lot in the last 20 and 30 years. And it will help you to understand why the attacker method became so popular recently. So probably most of you heard about security attack and how much, as we said before, Log4j and so on. So in a classic targeted attack, attackers had to invest a lot of time and money on comparison a single target, right? Before that, if I want to get to a very specific computer, it probably will take me much more time as an attacker than trying to share a dependency that will go all over to a lot of developers. For example, whoever writing his code in Python, I can just create a package that contains some security vulnerability and spread it to the world. So it will be much, much easier to make it for more organization and attack them. So compared to many relatively small software packages that are out of there, I can just attack to different places, different location, and I probably wouldn't need so high skills. Maybe some of them, depends how much it will be complicated, but it's involved finding on vulnerabilities and developing a working explorer for it. And basically we can attack more and more this way. So we can see here the difference and how much it costs according to Zerodium. So when we're talking about WinRC zero click, it's probably cost me a lot compared to just something as a dependencies that I can probably put somewhere here. So you can see that remote code execution exploit can cost you 1 million, as I said before, just for a single exploit, right? And which is the most expensive one is a zero-click RC exploit to Windows. And when attacking malicious open source software, for example, the options are endless, right? I can just share it. I don't know what I'm gonna get from it and when, but maybe someone will do a mistake. There is different way to attack when we're talking about the packages, open source packages in that case. It could be kind of a change in the name. It could be a version that contains something. It could be, we can show a lot of stories later on, but I'm sorry, I don't have too much time today, so I'll try to be focused. So I'm really encouraging you to check this list later, but let's take the fourth injection because it's pretty cool, PPR, Poison Pipeline Execution. This risk refers to the ability of an attacker with access to source control system and without access to the build environment, right? He can just reach out to the source control. In that case, for example, to whenever you're writing your code. So to manipulate the build process by injection malicious code command in or code or commands into the build pipeline configuration, essentially it's poisoning the pipeline and running malicious code as part of the build process, right? That's pretty cool. So I really recommend you to check this list later on. And let's move on to how to track changes, ensure integrity, right? How we can get or we can't maybe with this Giphy. So we basically run it, and in the old build, it worked perfectly, right? We have everything green, but suddenly we had issues when we're talking about promotion. What we should do now, right? How we can track that it changed and why. And this is the only the specific dependencies that making everything red again, or maybe we have multiple files. What we should do in that case? So maybe everything changed, or maybe just something specific, as I said before. Let's first thing that we need to investigate here is when you run the build, it can create an immutable snapshot of the build output, which become a release candidate. So think about the idea that you can have something that you can trust, right? You know it won't be changed. You can see the lock here. It's pretty cool. So you can trust it. It's our release candidate. It's almost there. We're almost publicly pushing it to the release. Why it's so important to create it? We want to make sure that we will release the exact artifact and can distribute it later to a different location that we trust, right? Like let's say that I have a different location, different servers that running my product, my application. Sorry. So I want to make sure that everywhere will get the same version, and I have it with some edge nodes, right? That running on different locations. And I want just to share it with the edge nodes, the latest and greatest version. How we can be sure that it's secure, right? Nothing's changed there, and the edge node will get exactly what I sent, right? Exactly what I try to create as a release, right? As a release bundle. That way, you can be sure that nothing has been changed, as I said before, and it goes across the various stages of the build into to production, right? We are making all these process. We have the development. I just close it as a release candidate, test it, integrate it, stage it, and production. So here is a quick example. Let's go back for the build for a second. If everything changed or a specific file has been changed, so with this build info, I can get a lot of information about my build. I can see the diff between them, which is very cool. I can run two different builds and see what changed exactly if the files is unchanged here, or I can see what exactly changed if this is a dependencies that I change between the version, and then I can easily start to investigate what's going on, why it's not working anymore. I can see the effective permission of the users that running it. And the most cool part here is the build info JSON. I love it. Think about the JSON file that contains everything you need about a build. You can see there all of the environment variable, if there is any information from security. You can see if there is any issues at all, and then you can easily create an automation about it. You're taking this JSON file, just do and run some automation, like if you are finding this and this, and when it's run, get the information somewhere and do tons of automation to understand better your build. So I really like this feature. It's called the build info, and we almost cover everything, right? So let's move on to the release candidate promotion. So we are here in the release candidate promotion, and in simple words, let's talk about promotion. You're promoting your release candidate, which just means you're making sure it's ready and it can't work better than that, right? It's ready, you just kind of close it and lock it, and now you can run it to production. And what is the difference between rebuilding versus promotion, right? Maybe some of you heard about it before, and I really like this funny GIF. So as you can see here, I see you have decided to complete rebuild, and I like it. I too like to live dangerously, right? So basically, it means that whenever you are rebuilt, you are trying to create everything again from scratch, kind of, versus promotion. I have something that it's almost ready. I'll just make some changes over here and then promote it to production. So the promotion pyramid, maybe some of you saw that before. We have a different step as part of our build process, and they are getting smaller and progress through production, right? So when we just started over here, you can see that we have the build, dependency time, and the amount of binaries that are very, very large in the beginning in the development build. And whenever we're talking about the local tests, integration test, staging, production, and the release candidate, which is almost ready, right? You can see that in the yellow line here. Here is the release candidate, which means that we are almost there. And we're gonna get to production soon, but you see it's getting smaller every time. It's a little bit smaller every time. And this is how it looked like, all right? At the very, very early stages over here in our build, the sources are converted as binaries, right? Everything is started from binaries. That of course we scan it already, we trust it. Remember before, we can have some plugins in our, even here in the IDE, whenever the developer just starting to write his software, we'll make sure he's using the right stuff. And then the promotion to pipeline starts, right? Moving to release candidate for the quality gates, where we started with the dev environment. Then we have the evidence over here to make sure that it's exactly like we want it to be. We can use the SBOM, for example, and the release bundle. Then it's moving between the different gates from QA to production, distribution, and then it's getting to our edge after we made all of these to make it better. So each gate has its own test and its own pass and fail condition, right? We want to make sure that if somehow in the dev we have some issues whenever we're running our pipeline, for example, we'll just blocking and won't move to QA, for example. So we started from the SBOM here. The SBOM contains what the build was initially run, stays with the release candidate, and it's append with the new evidence information as the piece of the software mature towards release. So I have here all of the information and my evidence to make sure that we can move forward. And if a release candidate survive it to the end, like really to here, it gets distributed to the deployed, which will be covered in the next section. Next session. Sorry for that. But again, think about the idea that at the end, our goal is to send anything to production, right? To make it also pretty simple, maybe automatically one day, but with the server that we can trust, that we can actually run and share it. So I think you may want to learn more about it. So I just added you here a link to start a free trial. You have two different trials and I can show you very easily how it works so you can see it right here. So let's start with the platform tool. I really like that I have everything in the free trial here. I can have it's for 14 days and here it's for self-education and exploration. So in this quick session, I'll just try to show you the platform tool. All right, so I hope everyone can see the environment and you can see the package view and we can take a look around. You can see here that I have some examples to better understand what's going on in this JFrog platform. And I have here the filters. I can see all the package types. I can see some custom views and what recently added. So let's see, I have different package types, right? I can see that I have here Docker, NPM, Hugging Face, PyPy, and much more in Maven probably, and so on. So here, for example, I can click on the example, see the versions that I have here. If X-ray scan here, it have the Docker layers, the build that run it, the location of the exact file. So if we talked about the idea that we need to find some files, I can easily go to the tree and see what exactly we have inside this Docker image for that case. And I can see much more. I have like the X-ray information, which is the security information. So if I have any security vulnerability as part of my build or just something that I'm trying to cache or whatever, I can easily control it. And here I have a lot of information about the platform, what is the supply chain security, and we can learn much more of it. So I really recommend you to start this trial and see how it works. And I was very happy to be with you today. So thank you so much for joining this session, and I hope you like it. And thank you. Thank you very much for being here today. If you have any question, feel free to reach out to me.